Let's start, children, with the very first sum of inequation. What is our sum trying to say? The actual question says solve the given inequations and graph the solution set on the number line. So the first sum says 2x plus 7 by 2 greater than 5x by 3 plus 3, where x belongs to integer. X belongs to I means x belongs to integer. So not only we are supposed to solve the inequation, at the same time we are supposed to plot it on number line also. What did I say in my earlier videos, if you can recollect? That before going for anything on the number line, before graphing it on the number line, what we need to have? Solution set. Compulsory we need to have solution set. For integers, the solution set will be presented in listing form, and for real numbers, the solution set will be presented in set builder form, right? So you are very much clear with that. Let's proceed. Now solving an equation is as good as solving an equation. Solving an inequation is as good as solving an equation. With a minor change, you will see an inequality sign, right? So it is not going to be difficult for you people who know how to solve an equation. Let's start with, what is the LCM between 2 and 3? The LCM between 2 and 3 is 6. So we first write down over here as multiply by 6 on both the sides. I repeat what we have done. We have the question in front of us. Since we have a fraction over here, by 2, by 3, LCM between 2 and 3 is 6, multiply by 6 on both the sides. Every single term, mind you, every single term needs to be multiplied by 6. When I multiply this by 6, 2 into 6, 12x. When I multiply this by 6, so if you want, you can literally multiply into 6, 2 1 times, 2 3 times, 7 3s are 21. Greater than, when I multiply this by 6, 3 1 times, 3 2 times, 10x. When I multiply this by 6, 3 6 are 18. Need not write down that x belongs to integer every single step. That is what we'll write down finally. 12x plus 21 greater than 10x plus 18. That's what we got it. Now shift all the variables on one side and constants on the other side. When I place this here, 12x minus 10x greater than 18 minus 21, 2x is greater than 18 minus 21, it's minus 3. X is greater than minus 3 by 2. X is greater than minus 3 by 2. Here I shall write down x belongs to integer. Dividing by 2, x is greater than minus 3 by 2, x belonging to integer. So let's write down our solution set. Let's write down our solution set. X is greater than minus 1 by 2. X is greater than minus 3 by 2, correction. X is greater than minus 3 by 2. Children, how much is minus 3 by 2? Minus 1.5. Minus 1.5. I need to know every now and then, and I have to cross check myself, that what is x belonging to? X belongs to integer. Is minus 1.5 an integer? No. So which is the very first integer comes in this particular category where x is greater than minus 3 by 2, that is minus 1.5. The very first number entering over here is minus 1. Right? Minus 1. What comes thereafter where this condition gets satisfied? 0. Thereafter 1, 2, 3. Sir, to what extent am I supposed to write down? It's an infinite series on the positive side. Dot, dot, dot. Comma here. Mind you, comma here. This comma is very important. X is greater than minus 3 by 2. That is x is greater than minus 1.5. X being an integer, x belongs to integer, right? Which is the first integer which is greater than minus 1.5? Answer is minus 1. I hope you know that in negative side, minus 2 is smaller than minus 1. Minus 1 is bigger than minus 2. Likewise, minus 1 is bigger than minus 1.5. So x is greater than minus 1.5. So it's minus 1. Now we got the solution set. What we need to do is we need to present it on a line graph. So we have learned that. We have learned that in our line graph, how we present it in our line graph. I hope you know and remember all those rules which we have learned. First, I shall plot my solution set. So it's minus 1, 0, 1, 2, 3. X belonging to integer, since I have already given the solution set, I need to emphasize on my solution set while plotting. So it's -1, 0, 1, 2, 3. It's going on and on, infinity. So recollect, refresh your concepts, recollect. What next? Should I darken this line? No, belonging to integer. So what? Sir, couple of dots here. What next? What next? What was the other rule? Sir, an extra element. Let me say 1, 4 over here. 1, 4 over here. And 1, -2 out here. We are not going to highlight -2, but certainly if you want, you can highlight 4. Why? Because it's an infinite series. So whenever it's a infinite series, that rule of giving an extra element doesn't make any sense, because one after the other it is going to go on and on and on. So whether you write down this particular 4 or you don't write down this particular 4 doesn't make any difference. But when this is possible, only when you have an infinite series. On the other hand, we have to write down one extra element. That's what extra element over here is, -2. Right, children? So we need to highlight -1, 0, 1, 2, 3. It's going to go to infinity. That's the reason we have darkened the arrow. Moreover, this suggests that whatever number comes on the number line, which are integers, all those numbers are going to come in this particular solution set. Right? Let's move to the next question. Here I have given you integer. The next one is what is real, so that you can differentiate. Though sum is not the same, it's not the same. Let's see, what is this sum trying to say? 5x minus 8 by 3 greater than or equal to 4x minus 7 by 2. X belonging to set of real number. X belonging to the set of real number. On the same lines as we worked out over there, we work out here also. What is the LCM between 3 and 2? 6. So we multiply by 6 on both the sides. Multiply by 6 on both the sides. When I multiply this by 6, the entire term, mind you, the entire term needs to be multiplied by 6. 3 1 times, 3 2 times. So it's going to be 2 into 5x minus 8. When I multiply the entire term, mind you, by 6, 2 1 times, 2 3 times, greater than or equal to 3 into 4x minus 7. This is why we write down or we represent our answer, or else you can keep in your mind 2 goes there, this 3 comes here. It is also, in your language, it is also termed as cross multiplication, but it is not cross multiplication. It is not termed as cross multiplication, mind you, right? But you can also tell yourself, this 2 goes here, this 3 goes here. But how we present it? We present it in this way, right? Now, open down the brackets. 10x minus, here it's going to be 16. Less than or greater than or equal to 12x minus 21. Variables on one side, constants on the other side. 10x minus 12x. Or you can shift this 10x over there in order to avoid minus sign. As we know, in inequality, when we multiply by a negative number, refresh your concepts, go to basics, follow the rules. When we multiply by a minus sign, the sign of inequality changes. In order to avoid all these things, what you can do is, you can shift this 10 over here. So it's minus 16, minus 21, plus 21, greater than or equal to 12x minus 10x. Minus 10x. How about here? Minus 16 plus 21 plus 5. Greater than or equal to, here it is 2x. Divide by 2. Divide by 2. What will I get? 5 by 2 greater than or equal to x. Or I can say that is x is less than or equal to 5 by 2. Meaning is the same. Why have I written this? Right? Many a times children find this difficult, but they understand this. When I say x is less than or equal to 5 by 2, they can realize, okay, x is less than 5 by 2 means something which is less than 2.5. 5 by 2 is nothing but 2.5. So the value of x is going to be less than 5 by 2. But maybe at times, I don't say it to every single child, but maybe this is what they find it difficult. The same thing is what I've written in some other form. Now I need to write down what is x belonging to. X belongs to set of real numbers. X belonging to set of real numbers. Sir, before drawing a line graph, what is necessary? Solution set. Is it belonging to real number? Indeed. Solution set is not going to be in listing form. It is going to be in set builder form. So solution set. Solution set. It contains all x such that x belongs to real number. X is less than or equal to 5 by 2. X is less than or equal to 5 by 2. Don't write down 2.5. Never write down in decimal. Never write down in decimal. You can write down in mixed fraction or you can write down in fraction. Never in decimal. Please keep this in mind. Now comes how to go for line graph. So we draw the line graph. X is less than or equal to 5 by 2. In mind you can calculate as 2.5 so that it becomes easy for you to plot it out. When I say 2.5, it lies between 2 and 3. So 0, 1, 2, 3. Next, by 2. As we have refresh your concepts in the previous videos, I have made you understand how to present a fractional form onto the number line. Since it is by 2, that means I need to divide between 2 and 3 into 2 equal parts. First part, second part. Right? I will stretch this, say -1, -2. Next, what is this 2? Sir, actually it is 2 in integer terms, but if I want to present it in fractional terms, then this is no longer 2. With a denominator 2, this can be treated as 4 by 2. With a denominator 2. Why? Because we have denominator 2. So this 2 should be treated as 4 by 2. For V to say, where is 5 by 2? This is 4 by 2. The next one is 5 by 2. The next one is 5 by 2. It's very easy now. What next? X is less than or equal to. Less than or equal to. Right? So since it is less than or equal to a dark circle. Less than. So should I move myself here? To what end am I going to go? Infinity, on the negative side. Right? It is less than 5 by 2. Negative side infinity. So this is going to be dark. This also. What next? Is it going to have all the decimals and the fractional in between? Indeed. So even this is going to be dark. What next? Sir, rule says one extra element. When we say 5 by 2, 3 is not regarded as an extra element. When we say 5 by 2, 3 is not regarded as an extra element. So one more extra element, 4. Actually, we went for 2 more to be on a safer side. It was because of these kind of fractional presentation only I said 2 more. Right? It was only because of fractional presentation I always said to be on a safer side 2 more. So this is how the line graph is for this particular question. I want my children to observe very carefully, both of them, one being x belonging to integer, so how we present it, x belonging to real number, how we present it. These are very basic sums, mind you. These are very, very basic sums. But to start with your inequation sums, we have taken these 2. As in further, we will take something higher order of these 2, right?